A massive object roughly the size of Manhattan is hurtling across our solar system at an astonishing velocity exceeding 130,000 miles per hour. Scientists have dubbed it 3I Atlas, marking it as the third verified interstellar object to ever pass through our cosmic neighborhood. However, this isn't merely some ordinary space rock wandering in from the void. Right from the initial sightings, experts detected an anomaly. The object's path exhibited hints of non-gravitational propulsion, a subtle yet detectable shift implying influences beyond the sun's gravitational tug. Initially, the notion seemed far too improbable to entertain seriously. Still, murmurs started circulating within the research circles. Might this colossal entity be driven by an engine of some sort, perhaps a nuclear-fueled mechanism? The chances of its course arising by pure chance are so slim that experts peg them at under 0. 5. Should that assessment hold true, 3I Atlas could represent not a random cosmic drifter, but an intentionally crafted probe navigating the galaxy. The true intrigue stems from the evidence itself. Early indicators didn't arise from wild speculative ideas, but from meticulous round-the-clock monitoring by committed skywatchers. Teams at facilities in Chile and Hawaii tracked its location relative to distant stars, logging each image with remarkable accuracy. These efforts yielded not isolated images, but vast arrays of measurements from instruments including Pan-STARRS, the Atlas Survey, and the Hubble Space Telescope. Collectively, they constructed an ephemeris, a precise timetable, forecasting the object's position at every interval. The crucial evaluation involved the residuals, the discrepancies between anticipated and observed spots. Even minor variances, mere fractions of an arc-second, might indicate external forces at work beyond mere gravity. Should invisible influences, be they organic or manufactured, be altering its route, the residuals would betray them through deviations or bends in the forecast trajectory. Nevertheless, following exhaustive verifications, adjustments, and grueling all-nighters poring over the numbers, the findings showed no compelling evidence of drive mechanisms. Officials at NASA's Jet Propulsion Laboratory and the Minor Planet Center affirmed that gravity alone accounted for its path, with no call for exotic propulsion factors. Indeed, incorporating any engineered influences only worsened the model's alignment. Per the established accounts, 3I Atlas is acting precisely like any ordinary celestial body. Yet science rarely wraps up so neatly. As the intruder presses onward, fresh sightings pour in nightly. Each gets scrutinized anew against the simulations, with margins of error tightening progressively. Currently, there's no support for artificial engines in the data. That said, past encounters with interstellar wanderers have reminded experts to brace for surprises, since a single upcoming reading might upend it all. The controversy has divided researchers into opposing factions. One side attributes the observations to standard comet behavior. They posit that solar radiation is merely thawing icy layers on the surface, expelling gas bursts that gently deflect the core. In their view, a modest release of carbon dioxide venting outward could account for the noted speed changes. Comets, after all, have pulled this trick for eons. But the enigma persists undeterred. Spectral analyses and imaging to date reveal no obvious powerful vents. The surrounding coma, a hazy envelope of vapor and particles, appears, yet its form aligns with routine solar warming, not targeted thrust. Here's where the alternative group enters the fray, spearheaded by thinkers such as A.V. Loeb. Loeb contends that the lack of evident venting, paired with the object's exceptional luminosity and odd path, cracks open possibilities for something truly groundbreaking. A nuclear-powered vessel constructed by the notion of an advanced society powering this object feels daring, even outlandish, but it aligns with some intriguing specifics. A fission device outputting gigawatts might, in principle, fuel propulsion systems strong enough to replicate the gentle speed increases noted in initial observations. Should that hold, 3I Atlas becomes far more than a chance drifter. It's likely a deliberate scout threading through close encounters with worlds, possibly scouting ahead. That kind of power source would unleash vast quantities of gamma radiation, neutron bursts, and thermal output, all of which our ground or orbital detectors should easily pick up. Yet, Nothing like that has turned up so far. Facilities such as Fermi, Swift, and Neowise have probed it thoroughly, finding no oddities across gamma, X-ray, or infrared spectra. To the bulk of experts, this absence stands as strong proof debunking the atomic propulsion idea. Were it real, the thing ought to shine brightly in spectra impossible to overlook. Even so, doubt persists. The surrounding haze and dim trail might conceal minor exhaust plumes too fine for today's tech to resolve. Sharper insights from the James Webb Space Telescope and Chile's Very Large Telescope could eventually settle it. For the moment, the argument endures between skeptics of the classic origins and advocates of the unconventional. Right now, the enigma intensifies due to its sheer magnitude. Photometric studies indicate 3D Satellite Atlas spans almost 20 kilometers, comparable to Manhattan Island's footprint. By comet measures, that's enormous, a true giant. Picture a chunk of matter rivaling a modest metropolis, barreling along at 130,000 mph through the void. A collision with our planet would unleash catastrophe on an unthinkable level. Fortunately, its route confirms a harmless skim through the inner solar system en route to endless exile. Still, its approach sparks inquiries deeper than dimensions. How come we missed it sooner? The reality is stark. Its approach arc emerged from the sun's blinding vicinity, a zone where even top terrestrial scopes struggle to see. Only when programs like Pan-STARRS and Atlas caught it did the intruder reveal itself well within our system's bounds. For days, stargazers rushed to gauge, verify, and monitor its trajectory as it drew nearer to vanishing point. The closer the scrutiny, the stranger it grew. Unlike Oumuamua or Borisov, the sole prior interstellar wanderers, 3I Atlas boasts city-scale bulk and vigor. Oumuamua measured scarcely a football field span. Borisov resembled a humble frozen peak. But this one, Atlas operates in its own category, hauling kinetic force we've never confronted. And here's the twist. Its trajectory. Distinct from sun-tethered orbs and icy bodies, 3I Atlas traces a hyperbolic arc. With eccentricity exceeding 1, it clearly hails from beyond our stellar neighborhood. It plunged in at roughly 137,000 against the sun's frame, velocity defying mere gravitational pull. Its exit pace ensures that after perihelion swing, it'll depart for good. No boomerang here, just a singular guest, a dispatch from the cosmic abyss, bound never to return. Scientists term this V-infinity, the surplus speed post-solar escape. For 3I Atlas, it's around 26 kilometers, sufficient to vault beyond the Oort cloud into the interstellar void. Its course carves the system like a lance, curving faintly to solar tug yet evading capture or undue drag. A brief brush, months shy of Mars's path, weeks at Earth's solar remove, then away, maybe eternally. The path of 3I Atlas feels less like haphazard stellar chance and more akin to a meticulously charted route across the system. World by world, the itinerary reveals itself as if designed by a navigator of uncanny accuracy. It starts off. On September 30th, 2025, the object will glide by Mars at roughly 13.9 million kilometers away. That distance might seem vast, yet to stargazers, it's remarkably near enough that spacecraft circling the rusty world can snag detailed snapshots of its glowing halo during the flyby. Just 2 weeks afterward, on October 14th, 3I Atlas will make its tightest approach to our home world, coming within 27.5 million kilometers. There's zero risk to Earth from this. Still, it stands as the closest any wanderer from beyond our solar system has ever come in human records. Ground telescopes here will finally snag a front-row view of something that set off from a distant stellar neighborhood. The journey keeps unfolding. By November 2nd, Venus enters the picture as the visitor skims by at a mere 27.2 million kilometers. The big climax arrives later. On March 8, 2026, 3I Atlas will swing toward Jupiter, slipping past the gas giant's turbulent clouds at 22.4 million kilometers. Every leg of this path is pinpointed not just to the kilometer, but to exact days and hours, brief openings that won't repeat for anyone alive. What raises eyebrows about this route is its precise layout. The path follows a hyperbolic arc, unbound by our sun, cutting across the solar system in reverse, against the flow of typical worlds and icy bodies. Experts highlight how these close shaves align so neatly, like navigating a slender pathway among the stars. Models estimate the odds of such a path arising by accident at under Baros. 005. That slim figure has sparked intense curiosity among researchers and wild theories among the public alike. For space experts, every rendezvous is a treasure. Probes at Mars will monitor for bursts of particles. Arrays on Earth will track shifts in the halo's shape. The Venus encounter poses puzzles in infrared wavelengths, and Jupiter's immense pull offers a final shot to gauge how the intruder warps spacetime on its outbound leg. These passes act as one-off lab tests, yielding irreplaceable insights, though some detect more than luck at play. The lineup Mars, Earth, Venus, Jupiter isn't just uncommon, it's streamlined for efficiency. Each comes in at a range ideal for sharp observations, yet always staying clear of any snag by gravity. Adding to the intrigue is the illumination. As Atlas nears Mars, the planet will shine just right. During the Earth skim, our world's tilt guarantees a clear facial view. Venus's bright layers will maximize visibility for distant instruments, and Jupiter's tempests will rage in plain sight for the sweep. To certain observers, none of this feels haphazard. It resembles a scouting operation. Astrophysicist Avi Loeb has been among the most vocal in highlighting this orchestrated dance. He posits that a crafted device meant to scout a star system would prioritize peak intel gathering while dodging easy spotting. The setup of 3I Atlas, he insists, matches that blueprint uncannily. Based on Monte Carlo runs, the likelihood of this chain unfolding randomly sits below 1 in 20,000. Doubters push back, noting the solar system's constant traffic from countless icy drifters and rocks. Rare setups are bound to pop up eventually. In their view, it's merely a fluke in the numbers, a stellar roll of the dice that turned out spectacular. Even so, parallels to past cosmic intruders are hard to dismiss. Back in 2017, Oumuamua streaked through, cigar-shaped and spinning oddly while speeding up in puzzling fashion, igniting endless arguments. But it was tiny, only a few hundred meters across. Now, not even 10 years on, 3I Atlas shows up a massive 20 kilometers across, weaving through 4 key planets. The schedule seems too perfect. Could Oumuamua have been the vanguard, with Atlas as the sophisticated follower? That idea links straight to the dark forest idea, the chilling notion that advanced societies stay quiet across the cosmos from sheer caution. Under that lens, such envoys wouldn't broadcast their presence. These enigmatic visitors would glide by in silence, gathering information before slipping away into the emptiness, sparking endless inquiries in their wake. Might 3I Atlas represent precisely such a sentinel, one that observes stealthily without drawing attention? Heightening the fascination are its chemical signatures. As researchers examined its surrounding haze, they detected an atypical makeup heavy on carbon dioxide but scarce in water. This proportion flips the norm observed in typical comets from our solar system. Such a profile hints that Atlas originated in a much chillier, remote region where CO2 frost could endure for eons. Certain experts view this as proof of extraterrestrial roots, while skeptics point to the vast variety across cosmic architectures. The object's luminosity only deepens the enigma. Photometric analysis indicate Atlas outshines comparable comets at equivalent ranges, yet stays within plausible natural limits. Nevertheless, its surface reflectivity or albedo stays elusive, obscured largely by enveloping particles. A few theorize it might feature a manufactured mirror-like quality, but nothing substantiates that claim. This leads inevitably to deliberations on humanity's response. Shortly after its detection, engineers at NASA and ESA revisited archived Project Lyra proposals for pursuing extrasolar intruders. Harsh realities prevail, however, with Atlas hurtling along at more than 130 Saturn or 61 kilometers. The current launcher could match its pace head-on. The sole viable option involves a gravity-assist swing by the sun, A spacecraft would plunge toward the star, igniting its thrusters at peak proximity to amplify velocity dramatically. The approach is hazardous, unproven, and the opportunity is fading rapidly. Come early 2026, Atlas will have accelerated beyond reach for any pursuit. This pressing timeline divides opinions sharply. Proponents insist we attempt contact, perhaps deploying a modest CubeSat-scale device merely to demonstrate our capability. Detractors urge restraint, citing the dark forest hypothesis. Should it prove constructed, any outreach might invite perilous scrutiny. Thus, the controversy intensifies. Does 3I Atlas drift as a mere cosmic drifter or arrive with intent? Is its path a freakish coincidence or a calculated scouting route tailored for surveillance? For the moment, certainty eludes us all. What stands clear is that this ranks among the most unlikely interstellar journeys documented, a stellar phenomenon compelling us to ponder if solitude defines us or if unseen eyes already track our existence.